Hi friends, welcome back. We are with the series Data Structures Decoded, looking after arrays in the linear data structures. Now we are in linked lists. So under linked list, we have seen how to create a linked list, how to insert a node in the linked list, and how to delete a node from the linked list. Now it is time to search an element in the linked list. So just want to know whether the linked list or the data in the linked list contains the required data or not. If it is containing, then we should say that we have found the element, and if required, we can also say where exactly it is or which node it is, and so on. So let's jump into what searching an element in the linked list means. So we have a linked list which we had created earlier, used many times in the previous sessions while creating, while inserting, while deleting the same data structure, the same linked list we are using for further action like searching an element. In this, let's assume that we are searching an element with a value of 40. So we just want to check whether 40 is part of the linked list or not, whether the data stored in the linked list contains an element 40 or not. So for doing that, we just can't just directly jump onto any node. So we always have to begin from the first node, which we call a head. So we begin with the first node, which we call head, and then look at the value at that node. What is the element stored in that node? And we find that it is 10, which is not equal to what we are looking for, which is 40. And hence we make use of the address where the next node is stored, and using that address we go to the next node and look at the data there, and again realize that this data also doesn't match with what we are looking for. Therefore we take the help of the address of the next node and jump to the next node, and there we find that the value at that node matches with what we are looking for, and hence now we can comfortably declare that we have found an element of value 40. We have found a node where the element value is 40, and so on. So that's where that node is, and this node can be anywhere from the beginning till the end. Therefore, in the worst case, the data may be at the end. So the worst case will be big O of n. So it's a linear time const time complexity we have. Let's take another example where we are looking for a value which is not part of the linked list. So when we are looking for a element which is part of the linked list, then we can comfortably stop whenever we find that element and declare that we have found, and we can uh, return back the position and other details, whatever we have found. But in case if we are looking for an element which does not exist, then we cannot stop in between. We have to reach till the end, and even after reaching the end, if we don't get the element we are looking for, then only we can declare that such element does not exist in our list. So let's begin our journey looking for an element 45. So we start with the first node, it is 10, not 45. Go to the second node, it is 20, not 45. Then go to the next node, it is 40, not 45. Then go to the next node, it is 30, not 45, and there is no more next node because the address of the next is null. So it says that that is end of the linked list. And once we reach the null and still we don't find what we are looking for, only then we can declare that the element 45 we could not find. So that's how we can discuss on that, but we are not convinced unless until we look at the actual code and then work on real time. So this also definitely is of order of n. So what we are looking for in the search is we begin from the head. So we define a new node called current, the pointer to the a node which we call current, and currently we pointing to the head of the linked list. We are looking for an integer x, and as long as we don't reach end of the linked list, we just keep doing this. And the current node's key, if it is equal to x, then yes, we have found the node whose value is what we are looking for. So just return back and say that yes, we have found it. If the current node's key is not equal to x, then let us move to the next node and repeat the same thing. So this thing we repeat till we get either a node with a value x, or till we reach the end of the linked list and still never get the chance to equate to x, only then we just return a false. So let's you can say algorithm for that. So let's work upon the actual data, actual code, and see. Yeah, here we have defined a function to search, and here we are, sorry, this is about the searching an array. We need to search the linked list. Yeah, so that's a code for searching linked list. I'm sorry. So here node is defined as a structure, and then we are looking for the, as we discussed in the previous slide, we start with the current node as the head, and then we keep just moving. And when we get a position, so we start with a value I equal to 0. That's going to say which position we have. And if we get a value which is equal to key that we are looking for, then we just return the value of I. So if it is found on the first place itself, then I was 0, so that I is in return back. If it is not in the first place, then we go to the second place, then we increment value of I. So I started with 0, now it has become 1. So when go back, and if it was found on the second place, then we say return 1. If no, then we go to the next one. So this loop continues till either we find the data which is equal to key, or we uh, have no more nodes to look for. So if we find any node which has got a value equal to key, we just return the value, the position of that. Otherwise, we keep doing this, and once we run out of all the nodes, then we don't find anywhere, then we just return a -1. So here we have a code to just insert the nodes just to create a, so we have created a linked list. So that's we pushed 60. So 60 is at the end. Then we pushed 50. So 50 comes before 60. So because this is a push operations, we are pushing that before the beginning of the linked list. So finally we have pushed 10. Therefore, the linked list now looks like 10, 20, 30, 40, 50, and then 60. So we just call that function and first print that what array we have and then see what element we are looking for. If we are looking for any element, that is what we enter it, and then we run that search code, and we get a return as a position. So if the position is not equal to -1, that means it will be from 0 onwards. Then we have found it. If it is -1 means we could not find that. So let's just run and check that what we are going to get. So we have created a linked list 10, 20, 30, 40, and 50. So let me check the whether element 10 exists or not, and then it says that 10 is found in the list at position 0. So this in C we have habit of indexing from 0. So this is 0 position, 1, 2, 3, 4, and 5 positions, and so on. So let's run again and try to find something like 40 now. So 40 is here, so that is 0, 1, 2. At position 3 we should get, so 40 is found in the list at position 3. So now let's check what if we are trying to look for one which does not exist, maybe 35. So if I just look here, this is not 35, 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 and then we come to end of that. And once we come to end of that and still we could not say that we found it, then at the end we declare that we have not found it. So let's check it. So it says that 35 is not found in the list. So that's how the search activity is done. That's how search activity is done. And that's a simple logic we are going to use. So as long as the we can move further, we keep moving, and at every step verify whether the data there is what you are looking for. If so, return true. If no, then go to the next node. Once you uh, have done with all the nodes, then you are having nothing to say, therefore say null or return a blank one. So that's what we are trying to do here. So if we find, then we return the position. If we don't find, then we return -1. And that's what is the idea of working on. So that's what we have about how to search an element. The next session, let us see what traversal is and how it is done and so on. So as of now, that's it from our end. So if you find our sessions of any interest, of any use, so please don't forget to like and subscribe the channel. Please share with your friends so that everybody gets the use of it. So that's it for now. Thank you.